Hello everyone, welcome back to my YouTube channel. As you all know me, I am Ruchi HP, the student of Sri Venkateshwara College of Engineering, Bangalore, from the Department of Computer Science and Engineering. And my today's subject is microcontroller. Topic: ARM instructions and pipelines. Contents: Introduction, ARM instruction, benefits of ARM instruction, understanding the ARM instruction set architecture, common ARM instructions, advanced features of ARM instructions, real-world applications of ARM instruction, pipelines, pipelines executing characteristics, conclusion. Introduction. ARM instruction is a tool that enables the developers to write and build the applications for ARM-based platforms. The pipeline is a ARM refers to the process of fetching, decoding, executing, and writing back instructions in a sequential order. Understanding the ARM instructions and pipelines is crucial for optimizing the performance in ARM architecture. ARM instruction. ARM instruction is a powerful tool for programming the microcontrollers efficiently. It provides a set of instructions specifically designed for ARM processor. ARM instruction helps to improve the code execution speed and optimize the memory usage. Benefits of ARM instructor: allow for the efficient use of resources on microcontroller, enhance the code performance and the speed of execution, facilitate the better control over low-level operation for greater customization. Understanding the ARM instruction set architecture. ARM instruction set architecture defines the set of operations that can be performed by the processor. It includes a wide range of instructions for data manipulations, control flow, and memory access. The ARM ISA is designed to be efficient, compact, and easy to understand. Common ARM instructions. The data processing instruction perform arithmetic operations like addition, subtractions, and logic operation. The load and store instructions transfer data between memory and register. The branch instructions control the flow of program execution by jumping to different parts of the code. Advanced features of ARM instructor. SIMD, single instruction multiple data. Instruction enable the parallel processing of data. The thumb instructions provide a more compact code size for memory constrained applications. The ARM Neon technology offers advanced SIMDA capability for multimedia processing. Real-world applications of ARM instructor. Embedded system in IoT devices benefits from efficient code execution and low power consumption. Automotive application uses ARM instructions for real-time control and sensor data processing. The industrial automations relies on ARM microcontroller for precise and reliable operations. Pipelines. A pipeline is a mechanism in a RISC reduced instruction set computer processor which is used to execute the instruction. A pipeline speeds up the execution by fetching the next instruction while other instructions are being decoded and executed. Fetch, decode, execute. ARM7 three-stage pipeline. The above figure shows a three-stage pipeline. Fetch loads an instruction from memory. Decode identifies the instructions to be executed. Execute process the instructions and writes the result back to the register. Following figure illustrates the pipeline using a simple example. Here is the diagram which is the figure name is pipeline instruction sequence. The figure shows a sequence of three instructions being fetched, decoded and executed by the processor. The three instructions are placed into the pipeline sequentially. In the first cycle, The core fetches the add instruction from the memory. In the second cycle, the core fetches the sub instructions and decodes the add instruction. In third cycle, both the sub and add instructions are moved along the pipeline. The add instruction is executed and sub instruction is decoded and the CMP instruction is fetched. This procedure is known as filling the pipelines. The pipelines allow the code to execute an instruction every cycle. As the pipeline length increases, the amount of work done at each stage is reduced, which allows the processor to attain a higher operating frequency. This in turn increases the performance. The increased pipeline length also means increased system latency, and there can be a data dependency between certain stages. The pipeline designs for each ARM families differs. For example, ARM 9 core increases the length to 5 stages as shown in the figure: fetch, decode, execute, memory and write. This is the figure of ARM 9 5-stage pipeline. The ARM 9 adds a memory and write back stage, which allows the ARM 9 to process an average 1:1 Hydrostone MIP per megahertz, increases the instructions throughput in ARM 9 by around 13% compared with an ARM 7. The ARM 10 increases the length still further by adding a sixth stage as shown in the following figure: fetch, issue, decode, execute, memory and write. This is the figure of ARM 10 6-stage pipeline. ARM 10 can process an average 1.13 Hydrostone MIPs per megahertz, have about 34% more throughput than ARM 7 processor core, but again at a higher latency cost. Pipeline executing characteristics. And the ARM pipeline will not process an instruction until it's passed completely through the execution stage. For example, an ARM 7 pipeline with 3 stages has executed an instruction only when the fourth instruction is fetched. The following figure shows the instruction sequence on ARM 7 pipeline. Here you can see the ARM 7 ARM instruction sequence figure. There are 4 cycles to be done in this ARM instruction sequence. The SMR instruction is used to enable the IRQ interrupts, which only occurs once the SMR instruction completes the executed stage of the pipeline. It clears the 1 byte of CPSR to enable the IRQ. Once the add instruction enters the execution stage of pipeline, IRQ interacts are enabled. The following figure illustrates the use of the pipelines and the program counter PC. This is the example of PC is equal to address plus 8. In executive stage, the PC always points to the address of the instruction plus 8 bytes. In other words, the PC always points to the address of the instructions being executed plus 2 instructions ahead. Note, when the processor is in thumb state, the PC in the instruction address plus 4. There are 3 other characteristics of the pipeline. The first, the execution of the branch instruction or branching by direct modification of the PC causes the ARM core to flush its pipeline. Second, the ARM10 uses branch prediction, which reduces the efforts of the pipeline flush by predicting the possible branches and loading the new branch's address prior to the execution of the instruction. Third, an instruction in the execution stage will complete even though an interrupt has been raised. Other instructions in the pipeline will be abandoned and the processor will start filling the pipelines. Conclusions. ARM's reduce instruction set computer-based instruction sets prioritize simplicity and the efficiency, enabling the fast execution. Pipelining enhance the performance by overlapping the instruction stages, although hazards require careful management. ARM's diverse the instruction set caters to various applications involving overtime to balance performance and power efficiency. Recent architecture emphasizes the parallelism and vectorizations for enhanced throughputs. The challenges include optimizing the pipeline designs while maintaining the compatibility across the architectures, demanding carefully trades-off. In summary, the ARM instruction set and the pipelines offer a versatile solution for diverse computing needs, continually involving the involving to meet the demands of modern applications. Thank you.